Xin chào. Hello, everyone. I am Melody from the APNIC Secretariat. Before we begin the Routing Security SIG session, the Secretariat needs to announce the results of the SIG chair election. I'm here to confirm the appointment for the position of Routing Security SIG chair. We have received 2 nominations for the position, but one of the candidates has withdrew their nomination right before elections. So because of that, Terry Switzer will be the elected Routing SIG Security Chair. Terry Switzer's nomination is published on the conference website for anyone interested. He has expressed willingness to serve and meets all eligibility criteria. Under Section 3.3 of the SIG guidelines, where there is only one eligible candidate nominated for a position, the candidate will be elected via acclamation in the SIG forum room. Terry Switzer will serve for 2 years from the end of this conference to the end of APNIC 64 conference in 2027. Congrats, Terry. Thank you, everyone, for your participation. The election result will be recorded in the SIG meeting minutes and also will be shared in the conference report. Thank you.
Hello, everyone. I'm Taiji from JPNIC, co-chair of this SIG. And happily, we will have chair here and the organization will be better. Before beginning of the presentation on the stage, I will talk about 2 things for attending this SIG, and I hope this will help value of attending this SIG, because this is not the academic conference, but we have a study presentation or other deployment presentations. Sometimes in our community, RPKI, IRR, or manners are important, or deploying is important, or like this. But from the technical aspect, we need more accurate, or we need to be on the same stage for the same understanding of the technology is or for and how it should be deployed. So please think about presentations, for each presentations, if you do the similar or same story for in your country, in your company, what should you do? Maybe you will have a similar role or similar saying for others. The second thing is that this SIG is very limited for both meaning. One is communication. There's not enough time to discuss each other. And another thing is that language includes me. There are so many languages native speakers are gathered here. So maybe we need to think each other. The party cannot use English naturally. But basic understanding of being here should be very similar. So please take your time during the break or during the lunchtime to discuss with presenters or each other. Okay, let's get started. Could you come to this place? Yes, pick that one. Come here and start your presentation. Me, I will present about the deployment in Vietnam.
Hello. Hello, everyone. My name is Nguyen Minh Hải. I'm from Vietnam. Today, I would like to present APKI deployment to answer the security routing in Vietnam. And this presentation will focus on the following key points. Vietnam Internet infrastructure, Internet resource, critical infrastructure, and routing security. And second, the current deployment situation and case study of IOV on the VNI's infrastructure. And the next step for API deployment to answer the security of Vietnam Internet resource. And first, the internet was officially launched in Vietnam in the 1997. After more than 28 years of continuous deployment, Vietnam Internet has grown larger, flatter, with a network infrastructure composed of various interconnected systems. This system are structured into robust and secure layer. The first, we have the network infrastructure that connects Vietnam to the domestic and international internet. This includes the network measure Vietnamese ISP, which have extended network coverage throughout the country. Traffic exchange between Vietnam and the global. And the second, there are the network system of telecommunication enterprise that operates primarily the domestic infrastructure, providing service for regional and local markets. And the third, we have ISP. Only ISP in the Vietnam National Internet Exchange, which acts as the national hub for interconnection. VNX is current for routing domestic traffic, optimize data exchange, and ensuring the efficient use of the internet resource. And the last, there are enterprise across various sectors, includes finance, fintech, education, government, data center, and content provider. This network directories million of internet users in Vietnam. In the National Digital Transformation Program to 2025 with a vision to 2030. deploy digital government, digital economy, and digital society, and nurture Vietnamese digital enterprise capable of global expansion. Vienna is also a key role in the national digital transformation by connecting digital platform as a natural and profit system. Vienna play a crucial role of the deployment of internet, which help to deploy, enhance, and improve the quality and security of internet in the Vietnam. And now Vietnamese have a over 50 member and more than 500 gigs capacity. And Vietnam Internet Resource. Until now, there are over 1,045 ASN and more than 16 million allocated IPv4 address. And IPv6 adoption in the Vietnam is also strong, with a rate of over 60%, ranking second in the Asian and seventh global. And you can see in the slide routing table in the Vietnam is over the 28 years is bigger. And there are having more 1,000 AS and 1,000 ASN S5 on the routing internet in the Vietnam, and more 65,000 prefix 65,000 prefix last 24, and more 28 million prefix last 48 IPv6. And now we have 2 or 3% ASN advertise IPv6 only in the internet. And issues in the internet routing in the Vietnam. So recently, Vietnamese organization and ISP have experienced several errors and hijacking of routing drives, which have affected their network operation and service. This issue can originate from international network and impact Vietnamese ASNs. About 90% these incidents are due to routledge. The scope for this incident includes organization and business that haven't deployed routing security solution are vulnerable to attack that control of IP reference or alter routing paths. Without authentication and technical errors made by an employee during routing configuration and intentionally leads to routing attack on other network. And what's the solution? And as we already know, RPKI is effective and widely adopted technology, and organization and country worldwide are deployed into protect routing and answer internet security from the IP and ASNs. We record the importance of RPKIs and consider its task to answer routing security. This why we have a promote in early and rapid deployment in the Vietnam, support them in digital signing resource since 2018. By the end of 2021, RPKI deployment rate in Vietnam was about 16%, and so very happy in that time. We have one ISP being a pioneer ISP in deploying and testing ROV. Currently, we have reached and currently we have reached 98% RPKI for the IPv4 and 72% RPKI for the IPv6. However, the adoption ROV remains very low. The key challenge includes operational hesitation around the efforts in ROVs, the complexity of updating routing policy, and the need for stronger industry consensus. APNIC and AVNIC has been collaborating and on promoting RPKI best practice. Also, Vietnam has achieved nearly 100% digital signing of resource RPKI ROA, and our RPKI ROA is remaining very limited. In this year, VNIT has pioneered the implementation of our RPKI ROVs at the VNIS. Because VNIS is a standard cable model with many organizations and enterprise interconnect at the VNIS. This brings practical value by ensuring secure routing operation among members. VNIS which officially announced and provide RPKI validation system for the domestic ISP and network organization, thereby accelerating deployment and ensuring the security of Vietnam Internet. And our objective are to deploy RPKI routing security validation on a VNS infrastructure, provide monitoring and alerting information to connect member and promote handle routing security incident in the at the VNS. And the last expand the provision RPKI validation system to domestic ISP and network organization, promoting deployment and assuring the security of Vietnam Internet. And the system component includes the first, we build RPKI validation system and software like validator. The validation software built using open source code managed and provide validation information to network routers via the RTR protocol. The system maintain a database of Internet resource origin information, IP or IPASN and global routing data. It supports synchronization with international database and performance audit data refresh. It also features a dashboard interface to monitor validation and system operation. And the second, deploy on the VNS routers. VNS routing system have been upgraded to support RPKI configuration, connecting to the validation software for routing verification. On routing, active VNS member organizations are validated to detect and mitigate security issues across the VNS infrastructure. And the last, monitoring and alerting system. This system will collect information on the routing operation, routing on the operation, including validation region, potential spoofing or misconfiguration. Just automatically send real-time alerts to connect member for timely response. A dashboard interface visualize RPKI validation active to support management, reporting, and assessment of the security of Vietnam Internet resource. And the VNS RPKI ROV system has been successfully deployed. On routing, information advertised through VNS has been classified by its RPKI validation status with 100% of IP prefix and ASN monitor and validate. Since its practical deployment in the March 2025, the system has successfully detected and report 8 cases of invalid route announcement in via VNA. This were reported to the respective member for verification and remandation. Identify and class with 271K announced routing information, mostly organizing from IP prefix and ASNs that have not yet reached ROAs. VNet has been informed and guide this organization to complete their ROA signing. And we have also deployed a lookup system to display our RPKI status of IP array, IP and resource. Happy network member knows the access status of their resource. Thanks to our effort and coordination with Vietnamese organization and business, nearly 100% the IP AS resource of Vietnam. Vietnam State Agency and on Vietnamese Internet Resort have been digitally signed with RPKI Airways. The number of Internet routing issue. The number Internet routing issue includes route list has significantly decreased, and next time to answer Vietnam Internet continue to larger, flatter, and faster, providing a solid foundation for the digital transformation. We have a following plan. Complete the transition to IPv6 only network by 2030. And the second, promotes multi-directional connection through VNS and ISP. Ensure 100% always RPKI for on the Vietnam Internet resource. And the last, promote the deployment of our RPKI ROV and enhance training, guidance, and support for organization and business in the ROA RPKI and ROV RPKI. Build system to monitor and collect information on the Vietnam Internet routing and provide alerts on the situation. And that's on my presentation. Thank you.
Thank you. We can have one question or comments. Before that, I will do ice break for you. My question is about the deployment. In Japan, it's difficult to it's not only Japan. It's the point is that the difficulty is how we share the same recognition with people wider than we can see. And we need to encourage people to do something like creating ROA or deploying ROV. How did you act for Vietnam ROA coverage, and what do you do for ROV development?
Yes. In my presentation, so I have a slide. I talk about the plan and the plan in the Vietnam. We need to recognize the importance of RPKIs. So we have conducted RPKI training course for Vietnamese telecommunication company and support them in the digital signing resort since 2018. And we have built many workshop. We have built many and support East major ISP in the Vietnam. So push ISP signing also their internet resource.
Thank you. Thank you, Min Hai. Please give your large applause for him. And thank you for your presentation.
Okay, thank you.
The next speaker will be Mr. Walt. Hello, Mr. Walt. Are you okay? And what time are you in?
We are almost 7 o'clock in the morning.
The voice is smaller than we expected. So could you raise the volume for remote attendees? Oh, maybe, Mr. Walt, your mic volume may be lower.
I'm trying to put it up. Is better?
Okay, it's getting better.
Okay, I can put
Could you
it
speak
louder.
something, or could you speak something more before your presentation?
Yes, I am speaking at this moment.
Okay, it's a little bit small, but we can hear. Thank you, Mr. Wall is arranging his volume. This time, I need to explain about this program. We have CFP period, and we review the all incoming presentations, call for presentations. Then as a result, the result is 3 invited talk is gathered this time, and 1 presentation from student study. So the very last part is a presentation from student from Japan. Mr. Walt, can you speak something for?
Yes, I've put on a microphone. Is that better?
Oh, yes, that's very nice, better than it. So you can start your presentation.
Then I'm starting to share my screen.
Yes.
I take it that you can see it. And I'm trying to, yes, there it is. So I think it's okay now, right?
Perfect.
Okay, then I will start my presentation. My name is Wouter Nathuis van der Borgt, and I'm the coordinator of an Internet Governance Forum dynamic coalition called Internet Standard Security and Safety Coalition. And what we will do today is that we will look at what is at stake here. So the domain name system and the global system for internet routing are both fundamental for the functioning of the internet. And I think that is, you're focusing more on RPKI. This study focused on both, but also have to say that no matter what internet standards you have to convince your boss of, probably these arguments that we will present today will work. But what is the problem really, that technical teams often focus mostly on the technical merits when advocating for security standards implementation. And this narrow approach has led to limited adoption. Deploying these standards creates inherent security benefits for an organization's entire ecosystem. It protects customers and suppliers, employees, and the internet users by safeguarding their vital information, including its own. But before we go into these arguments that perhaps could incentivize decision makers to make a different decision, I will present what IS3C is and why we did this toolkit. So, as I said, we're a United Nations Internet Governance Forum and Dynamic Coalition, and that is a voluntary group of people working on a specific topic. And we work on to advocate the deployment of new generation security-related internet standards and best practices. And we do that because adoption of many standards around the world are far from suboptimal and sometimes even dismal, and some in countries do better than others. In the past, we've had 9 working groups, of which 5 are still active. You have 4 reports and 2 toolkits, and the reports are on IoT policy deployment around the world, internet standards in tertiary cybersecurity education. We looked at public procurement of security by design. We created a toolkit with the 23 most urgent internet standards to deploy. And our last report, published only a few months ago, was on the economic and political consequences of getting post-quantum cryptography wrong. And finally, we have a toolkit that we present on today. But let's have a look why this is so important. I think that many people in the internet world will know this cartoon. It's years old already. We see all this gear in the left, and on the right we have Dave with a t-shirt saying, "I'm the human error." But let's look at this picture in a different way. What can Dave, usually a home user, consumer, actually do to make himself more secure and safer? But the onus here is put on Dave. So what can he do? You can look at him, he's presented as a stupid user. You can see that he's dumb. You can see that he's an obvious slob. But let's face it, Dave is you at home. It's your mother. It's your little cousin. It's the local butcher on the corner of your street. And it's every company using some sort of ICT service from somebody else. Because what can Dave do about deploying DNSSEC? What can Dave do about RPKI? How can Dave make websites he uses more secure and safer? How can the hardware software that he buys, the services that he gets from the internet, and let alone all sort of other internet standards that he will probably never even have heard of. So perhaps he tries to buy more secure, but large governments and large companies and governments can buy secure by design and should have started yesterday to do so, but most do not. So why are we not organizing ourselves better and match the dark side's efforts? Why are we on the good side not testing the internet on flaws where the dark side does 24/7 a day? Why do we keep falling into the same trap with each new product or technique? Why do we keep buying ICTs without demands for security by design? And why do consumer organizations not test the ICT components in products? And I'm not saying here that we can do without the commercially offered security services. I'm saying that we also need to move from mitigation of breaches to prevention of said breaches and the deployment of internet standards and ICT best practices will help us plug these holes on the internet that we are discussing today. So let's shift responsibility and accountability from Dave to the corner on the other side. And that way, Dave will not even have to think about a lot of mistakes he could make on the internet because that option is no longer offered to him. So why is deployment lacking? I was able to do a study 5 years ago, and we came up with a multi number of almost excuses for not deploying. So there's no level playing field. Why would I deploy if all my competitors do not? When there's no demand, then there's no offer. And the time to market usually prevails over security. It's about cutting cost, because the more secure you are, the higher your cost is, and your competitors look at the no level playing field, do not have that cost. There is a lack of any pressure to actually deploy these standards, not from a government, not from industry, not from consumer organizations, nothing. And this is something that has to change. And this is just a number of the arguments, and we'll come to the technical arguments in a moment as well. You can find the report here, but I just before my presentation, I put also the link in the chat. We can find all our reports. So what needs to change? And that is an awful lot. There has to be put some form of pressure on industry to deploy. But how can we do that? For example, through regulation. And that is something everybody advised against 5 years ago. But we can see that the European Commission is starting that discussion and hopes to have a list of internet standards you have to deploy by 2027. The Dutch government has for its own, at all levels of governments, a deploy or explain list of 46 standards that a government has to procure on. But I'm not familiar with other governments having that sort of lists at this point. But I can be wrong because our research is 2 years old now. We can have economic pressure from companies saying, I'm not going to buy anything if you do not have DNSSEC or RPKI. So then I'll go to somebody else who has. So that's on procurement. Through procurement, we have the biggest economic pressure possible. I'm not doing business with you if you don't have these standards. As I already said, the testing. Why are we on the good side not testing 24 hours a day to find vulnerabilities? We're waiting for them to be discovered by usually bad guys. We can raise demand for security. We can coordinate testing for vulnerabilities. We can help create a level playing field, and finally raise awareness of decision makers. So as I said, what is the problem statement with the deployment of these standards? I think that when you look at this text, you need to keep in mind that there are two distinct implementation scenarios. Each requires a different approach, and I will skip that in this presentation, but keep in mind that there are two scenarios. The first one is when you have to implement these standards into your own infrastructure. And I think where RPKI is concerned, that is usually the case. I think the presentation we just heard from Vietnam is all about deploying RPKI within the own organization. But when you're a regular not internet company, then you will want to know if these standards are there or not. So you could have a procurement list saying, I want you to have RPKI because otherwise I'm less secure because of your lack of deployment. And the same goes for DNSSEC or HTTPS or a secure website builder, etc., etc. So we all understand in your community that it's completely necessary to have the level of security. And still, numbers in most countries are far from 100% with RPKI, although I'm told that these numbers are rising fast in the last few years, which is of course very good news. But for DNS, the DNS security, those numbers in some countries are far from optimal or even dismal. So in other words, what can you do when you have to deploy? What are you facing? This is the technical people who were working on this project, and we'll come to them later at the end of this presentation. What they recognize are the following constraints. So things can be extremely costly and that the resource, we don't have the resources in our own company. We don't have the knowledge. And that is something which I've been told is sort of overrated, but it's something that bosses think of because it's difficult. They don't understand it, perhaps. They don't understand why it's important. So it will probably be very complex. And it's of technical challenges, and they don't know where to start. And if you only look at the technical arguments, they will probably be convinced that it's complex and technical, and it will cost a lot, and you will have a lot of resource constraints. Very often, bosses see it as an extremely low risk. And we all remember the attack from Russia on this Ukrainian administrative organization, very small, insignificant, that shut down the whole world. So when I understand Maersk company, the huge shipping container company, the technical people told them, Microsoft has really pushed this update. We really need to do it now. And then the board said, when do we do this? Usually, oh, a week from now, then let's do it a week from now and save cost. And that cost them about $1 billion. And only thanks to a power outage in Ghana, what I understand from what I read, that was the only reason that they could start updating again, because Ghana was not infected. And they only found that out about a week after they've been shut down. So only because of a power failure, they could get their systems one by one up around the whole world. So by not updating, that cost them about $1 billion. And that board will probably have learned this lesson, but others still see it as a low risk. There's also a lack of awareness and education. I already said that we as IH3C did a study on education and skills in the tertiary computer science, cybersecurity science around the world. And we had responses from 66 countries, and we found that internet standards and the reason why they exist are very often not a part of tertiary cybersecurity education. So in other words, they only focus on how to make money, not on how to prevent. And as already said, with the Maersk example, organizational priorities and decision-making processes can easily stand in the way of deploying an internet standard. But why is it so important? And that is where we proposed a new narrative. I think that where the deployment of DNSSEC and RPKI, they represent a part of the crucial foundation of national cybersecurity resilience. What I don't have to explain to you because you will probably know, but we always talk about the public core of the internet. And people usually start thinking about cables and about routers and about all the other stuff, servers that we need to connect. But what is it that makes these connections possible? That is the internet standards that make up the core of the internet. So they are an integral part of the core of the internet. And yet they are often not recognized as such in papers that are written internationally. So we need to start protecting this core of the internet. And we do that by using more secure updates, more or less, of existing standards that were created in the 70s, 80s, and 90s of the previous century. So the consideration of the implementation of the DNSSEC and RPKI is part of a strategic approach to regulatory compliance and cybersecurity best practices. So there are many ways in which your company may have to offer this, because there's a duty of care in many countries that is in consumer law, for example. So that is something where you can convince your boss, this is something we have to do based on duty of care rules, for example. But from there, it's for commercial organizations that the deployment of DNSSEC and RPKI offers compelling security and business advantages. Because if you're more secure than others, it's something you can advertise. And you're more secure for your whole environment. So you create a secure environment for the rest of your country. So there's more or less a moral obligation, dear boss, to uphold these standards for the benefit of society as a whole. And I think that when we look at it from this angle, it's no longer technical. It's moral, it's economical, it is strategic, and it is common sense to deploy or procure these standards. So I think that it will make it possible to convince bosses to look at it from a different angle so that they allocate resources and prioritize initiatives that can be challenging, especially in larger organizations with complex decision-making processes, but they need to understand that this comes from a totally different angle. And hopefully that will work. So concluding, I think that now that digitization is impacting every aspect of our societies, the security and resulting trust in the DNS and routing infrastructure become increasingly important. Our online lives and the ambitions that we have globally to reap the benefits the internet brings for all, including those that are not yet connected, are completely dependent on the secure functioning of these underlying building blocks. So we talk about safeguarding, we're talking about reputation, we talk about brand reputation. We're talking about protecting critical services, our vital information, and the related infrastructure. And it's a strategic investment in a future that enhances brand reputation and helps ensure the integrity and authenticity of online services. With the ongoing digitization of our societies, online presence should be considered part of an organization's core business. And as such, it is imperative that considerations regarding DNS security and RPKI are included in its strategic plans to promote trust in online presence and the provision of online services. These are the people that made this report, this toolkit. It's more or less a toolkit. And you can see that they're very, very diverse and from almost all continents from around the world. This effort was led by David Uwerman of ICANN, and he is the principal writer of the toolkit, and Bastiaan Goslings, who at the time was with the RIPE NCC and is now with SIDN, the .nl organization. And I myself, and as you can see, I was not married yet at the time. I was the coordinator, making sure that everything happened and wrote part of the introduction to the report. So, as I said, this was sponsored by ICANN and RIPE NCC because they both deemed these standards to be of such importance that they provided the resources to do this work and made it possible for me to find the people to work with, and from there make sure that all the processes were right, and we presented at the Internet Governance Forum of 2024 in Saudi Arabia and Riyadh. So if you want to learn more about IS3C, this is our website. You can find the working groups that we're working on at this moment. You find all our reports in there, including this one, and I've put it in the link. If you want to join, however, we have a mailing list that you can join, and we are looking for people that we can work with in the future when we have new projects, so that we have the input we need to come up with the right reports. And probably the next step is on the deployment of the post-quantum cryptography. How are we going to organize the world to make sure that we move before, for once move before a new device, in this case a quantum computer, goes live, or a strong enough hybrid computer goes live, so that we're protected. And some people say we have 5 years, others say we have 15 years. But if somebody has a eureka moment tomorrow morning, then all of a sudden we have a strong enough device to do everything to the security we have now, so that the world has become insecure, but we will become insecure almost altogether. But we can prevent that and make sure that this new technique does not get deployed before the quantum computer goes live. So if you're interested to join, this is the link. You have to go to the Internet Governance Forum, and from there find the dynamic coalitions. It's extremely difficult, but this link, if you make a photo, then you can join immediately and you will hear everything that we're planning to do. So this is the end of my presentation, and I will stop sharing my screen. And I thank you very much for your attention, and I'm of course available to ask questions. Thank you.
Thank you, Mr. Welch.
I'd like to wait for from the question or comments on the floor. So please come up to the floor mic, please. Please state your name and.
Mr. Kok, right, NCC, asking this out of personal interest. You are describing a collective action problem as something that you can use as an aspect of a better product, of something that you improve. Has the team also thought about the financial risk angle of cybersecurity and data security?
And do you look at it from the side, the financial angle to deploy, or the financial angle that can hit a company when it goes
The
wrong?
financial risk angle that the auditors worry about and have to write up as a risk to the company, like Mars now maybe needs to do.
I don't think that that was very explicit, but it is implicit. So that the what is often looked at the inside, we found, is that they're looking at the cost of deployment. And one of the arguments we're using is that this is also about the risk that you look at, and that it is not a low risk as is often perceived. When I talk to people about cybersecurity, very often I hear back, but this is not about me. This is about somebody else. So the perceived risk is extremely low, while it isn't. So one of the arguments is the cost that can be incurred when things go wrong, and so that is part of the arguments used.
Thank you.
You're welcome.
Any other questions or comments? Nothing? Maybe one question from online.
More a comment than a question. Hi, I'm Sukha from APNIC. On behalf of everyone, I'd like to just say a big thank you to Taiji-san for his service as acting chair for the Routing Security SIG this year. Please give him a round of applause. He has done an amazing job this year, and we look forward to your leadership as you continue as co-chair of Routing Security SIG. Thank you, Taiji-san.
Thank you. But please applause for Mr. Walt for his exciting and very informative presentation. Thank you.
You're welcome. And should there be any questions or in the chat, I'm here till the end of the session. Thank you.
Okay, the next session will be your presentation. Okay, if you uploaded your slide.
Yes, I already uploaded.
Then he will.
Thanks. Should I start or can I start? Please. Okay.
Do you need an introduction?
No, it's fine.
It's fine. It's fine.
Can we go to the front? Can we go to the first page, please? Anyway, in the control. Okay. Hello, folks. Very happy to be back. I'm Zhou Taoliu from Tsinghua University. In this talk, I will basically discuss several challenges and technical innovations in BGP protocol that we have been thinking in the past few years. All right, so the content of this talk, I'll be as to be quick, so not holding everybody here for a long time. So we'll go briefly of the history of the BGP and understanding the key technical challenges over there, and also we are looking forward to how we can build a next generation BGP. So if we can, according to sort of like the common understanding, like the current BGP is what we call the BGP4, which has been over 30 years. This is a very
a long period of time, considering currently the AI models, they release a new model every 2 weeks. So, but we haven't have a new BGP5 for 30 years. So we need to sort of like to be faster. So the current stage of the BGP4 have several problems. Probably we already heard of that. So we identify 3 key challenges over there. The first is the security, another is the manageability, and another is scalability. For the security, I think the majority of audience know we are looking forward to push the RPKI stuff, which is a great way to solve the security problem. For the manageability, I think BGP misconfiguration is a very important issue that can cause large-scale outages in the real network. And for scalability, and BGP as a distributed system is always facing the scalability problem with the rapid growth of the routing table size. And also there is, because of the static semantics of the BGP limit, we are seeing more and more, restrictions in having a evolving demand of services. I think in 2023, about 2 or 3 years ago, the ISOC identified 3 core threats to the current internet routing security, which includes BGP hijacking, route leaks, and address spoofing. This is they have a very long sort of like the NCC asked the ISOC, so can you please tell us what is happening of this internet security, and they identified 3 major threats. This is a very long document that's very informative, and encourage everybody to read it. So the manageability challenge here is the butterfly effect of the very small misconfiguration. I think a lot of the real world BGP problems were actually caused by the manageability. The misconfiguration, not necessarily malicious, can cause a lot of the actual outage to the network. And currently the enterprise or the industry deploy a lot of routing anomaly detection systems to sort of like reduce this kind of outages caused by the BGP misconfiguration. But the problem is that routing anomaly detection at scale is challenging, and you have to process a lot of updates, and you have to make sure the false positive is low. There's a lot of other back and forth deployment requirements that has to be satisfied before we can release this product into production. And the scalability challenge of BGP is always persist as the distributed systems. There's scalability concerns regarding like the convergence time when there's network outage, how we can converge the BGP route as quick as we can. And also, as an internet, probably internet is more than just a sort of like a connectivity network. People are trying to sort of like make the internet more innovative, more adaptive to the applications. But the BGP routing has not been able to do that because BGP routing is really simple. It has very rigid or very simple configuration. What with the ISP can do with that. For the technical innovation over the past few years of the BGP protocol, I think in terms of security, there are 2 recent very well-informed, well-known protocols. One is called RPKI, another is called BGP SEC, and everybody I think in this room pretty familiar with this one. The RPKI is primarily to solve the route origin validation, which means it tries to prevent someone to announce and route on behalf of other people. And the BGP SEC is another more, very academic protocol. Actually, BGP SEC. It's a very, very good protocol with great security benefits. It has a provable secure properties, but the problem is the BGP SEC is have very low deployment over the past few years. If someone have attended the IETF meeting, so the BGP SEC deployment ratio is really low currently. This is in the RPKI basically timeline for the RPKI. it has a public key infrastructure to cryptographically verify the association between IP prefixes and ASs. And over the past few years, we see great RPKI deployment. I mean, the ROA is number of ROAs increasing dramatically. Although the ROV is still kind of lagging behind, but yeah, at least we are seeing progress. That's a very good. That's a very, very good sign of security internet. But the real issue happens on the BGP-SEC side. So the BGP-SEC have become an RFC for around 10 years. And we are seeing very limited deployment in current BGP-SEC. The primary reason was, to my understanding, was because of the lack of incremental deployability of BGP-SEC, which means if I deploy BGP-SEC, I cannot protect myself. So why bothers, right? So I think that's the problem. The community is why they are reluctant to deploy BGP-SEC. And also, a lot of academic research also found that BGP-SEC, although it has the great security problem, but it still can have some security vulnerabilities in some corner cases. But yeah, I think that's not the major reason why BGP-SEC does not have a very good deployment ratio. So over the past few years, our team at Tsinghua University have tried to solve this problem from multiple ways. Our philosophy of attacking BGP security is sort of like we want to have protocols that are currently compatible with the current internet. So in the past maybe 20 years, there are a bunch of professors from universities. They think the internet design is garbage. There's no way to secure the internet. So that's why they propose multiple what we call future internet architecture in the past 20 years. So after 20 years, everybody knows that the internet is still there, and so that's why from perspective of our research, we want to have something that is compatible with the current internet. So we do not want to start from a clean slate. It's difficult to start from a clean slate for internet. So the two things our team has been worked on primarily in the past 2 or 3 years is called VRO and FCBGP. So the VRO is actually a complementary protocol to the RPKI. The primary reason we have the VRO is we want to have multiple source of authoritative data to make the sort of like the data of the RPKI more trustworthy. Because like there could be some garbage data or some wrong data that was polluting the RPKI source, and we want to have multiple sources so we can cross-check to make sure there's no sort of like wrong data to make the RPKI verification more reliable. I think that's very important to ensure that in the future the ROV, when it enabled, will not have many side effects. Another protocol we are working on that called FCBGP, which is trying to solve the problem of BGP-SEC. So as I said, the BGP-SEC is not incrementally deployable, which means the deployer does not have any benefit. So why become a deployer? So the FCBGP have a way of sort of like having more security benefits, even if there's only partial deployment. So given this time limit, I will not go deep inside these two protocols, but there are a lot of materials open online for these two protocols. We have been submitted multiple RFC draft for FCBGP, and feel free to check if you want. And this is some industry practice in routing anomaly detection. So we have collaborated with major Chinese operators on their routing anomaly detection systems, including China Telecom, Unicom, and Mobile. And they are very sort of like enthusiastic about getting a real-time, accurate routing anomaly detection, so that they will not be messed up when there is a BGP misconfiguration. The problem here we're facing is again the performance there. The performance lows in terms of two ways. The first is the capacity or the throughput. It is difficult for them to process this large-scale routing anomaly detections in real time. So it takes a long time for them to process this routing, and that will slow down the operation. The second issue is the high false positive rate and lack of interpretability. So if there's an alert from the system, most of the time this alert could be and false positive. And to make sure this system does not cause, and the network operators have to look inside this alert if there is a false positive. And if there are too many false positives, the network operator teams is overloaded. So another second reason is they want to have something that have very low false positives. And last year we have an academic paper that was published in Security, which tried to solve these two problems. So we want to have a real-time detection systems, and meanwhile the system have very low false positive. And this paper has received multiple awards from these conferences. And also, this part of this system has been deployed in China operators. Okay, this is another thing for BGP, as I said, for the BGP innovation. Like in the past 20 years, maybe there are a bunch of what we call future internet architecture. Currently, there's most of them are more or less stay as academic proposal, but one exception is the Scion network, which was initially proposed by Andrew Perrick from CMU and ETH. Scion is a completely different new network architecture. It tries to redesign the internet from a clean slate. So it does not use BGP at all. It does not use anything at all. So it's have their own way of organizing all the ASs, have their own way of routing, path validation, all stuff. Over the past 10 years, Scion have to gradually grow from a regional network to a larger network right now, and they are currently have sort of like multiple nodes across the world, and they are trying to be serving as a backup or fallback of the internet. So their philosophy is like, if you see your internet is slowing down, and there could be some Scion connection for you, so you can switch back to use Scion. This is a very interesting idea. So we basically having another second another overlay or something like secondary to the internet. Finally, I would to sort of like having some basic discussion of if we want to be bold. Okay, if we want to be, okay, let's say we want to have something new. How can we have a BGP5? As I said, BGP4 has been there for 30 years. If we want to have BGP5, what it should look like? This is some very sort of like still experimental or still on academic paper, but I want to share with the audience. So hopefully you will get some ideas from what we are thinking about there. When we think the BGP5 things, we want sort of like go back to the key of the internet success. We want to study the internet technical success factors so that we can, build these factors into the next generation BGP. So here we identify 3 things from the current BGP to a new BGP protocol. So we identify 3 aspects. From lower is like the current BGP system does not have any trust verification system built in. So you basically, the trust is you assumed your neighbors are trustworthy, and they are not verifiable. So from the very beginning, we want to see in the next generation BGP-SEC, for the next generation BGP, we want to have the trust to be verifiable. So you don't have to trust anybody. You can verify their trustworthiness. This is the bottom layer. And the second layer, we want besides the BGP policy right now, we want to have something adaptive. This is where AI could help, because AI is data-driven, and it can help you to identify your best policy for your routing or for whatever. And so in terms of manual configuration, we want to have some AI-driven policy, routing policy engine that can understand the routes and generate the routes. And finally, on the forwarding side, there is the router currently, they are becoming more programmable than ever before. Probably in the next few years, we can have more easy way of programming the router so that we can have more flexible routing forwarding policies. Given that we have this 3-layer BGP next generation architecture, the first one is the underlying layer is called the connectivity plane. So the connectivity is basically only for setting up the connectivity. There's no other policy. There's no other routing selection basic stuff there. We want to have a physical connectivity map across the internet. And then the second layer is the native trust. So while we built this connectivity, we want to have something called verifiable intent or verifiable commitment to verify this intent, to verify this connectivity. And finally, with this physical connectivity, there could be sort of like the policy plane where like the programmable AI-driven optimization can be applied on. So at the high level, we want to decouple the current BGP router selection with the physical topology. So first we built a physical topology, which is sort of like verifiable. And then with this topology, we can do sort of like AI-driven operations. That's basically what I described here. So we have a connectivity plane, which is only for connectivity, reachability. And we have a trust plane to verify this, verify the credential or verify the correctness of this connectivity plane. And eventually we have this policy plane that allows AI to help the BGP to work. And this is sort of like how we think mentally, imaginary, how we can gradually move from BGP4, the current BGP, to BGP5. We want to make sure it's backward compatible. It does not start from clean slate. It can still support legacy BGP4, and eventually we'll go through multiple steps to go through BGP5. All right, thank you very much.
Thank you. Let me going to the next presenters, because the next presenter is the very first time to present here, so he will need accurate time for him, I think. So if you have any questions or comments, please continue on the floor during the break time. Thank you so much. His name is Taiju, and I didn't recognize before he's coming this time. He was fellowship attended for the previous APNIC meeting, the fellowship from JPNIC. Okay, you got ready? Okay. The stage on yours. Okay.
Check. All right, everyone. I'm going to start my presentation on future challenges for ROA validator and proposed solutions. Let me briefly introduce myself. My name is Taiji Goto. I'm currently researching routing security as a master's student at the University of Nagasaki. I'm particularly focusing on research into operation of ROA validator. ROV allows the validator to reference the tar file and retrieve ROAs from a number of repositories. The ROAs are then compiled for each record and sent to the router as a VRP. And the router compares the lib and VRP to perform ROV. We have been researching the role that validators play in this data flow. The number of ROA registrations has been increasing since 2019. And currently the ROA registration rate is about 60%. Assuming that the registered ROAs will continue to increase, we investigate whether the validator will be able to perfectly acquire the increased ROAs and continue to perform perfect ROV. We consider possible consequences of an incomplete ROV. There are two main reasons incomplete of ROVs occur. The first is that some ROVs may be lost due to network issues with retrieving ROVs from multiple repositories. The second is when some ROVs cannot be retrieved due to operational errors on the part of the repository. The impact of an incomplete ROV is currently small because many organizations operate with not found routes also installed in the lib. However, if the rate of ROA registration increases in the future and not found routes are rejected, incomplete ROVs will have a significant impact on routing. We will focus on this situation. Let me explain what I said earlier using a diagram. Regarding network issues, when the validator retrieves the ROA from the repository, it's synchronized using RRDP or rsync. If this synchronization fails, the validator will export a VRP to the router with some of the ROA missing, resulting in an incomplete ROV. Regarding operational errors on the repository side, if some ROAs cannot be retrieved due to an error on the part of the repository operator, an incomplete VRP will be sent to the router, resulting in an incomplete ROV. Incompletion of ROV occurs. A route that would usually be treated as valid will be treated as not found. If a policy is set to reject not found routes, the route information in question will be rejected. If the route has a close relationship with your own AS, this can have a significant impact on routing. It is obvious that network problems can occur. Is it possible that operators of repositories can make mistakes on their own? The answer is yes. Since we first encountered this question, we have been monitoring the number of ROAs per repository. As a result of monitoring, we have found that some repositories have experienced a 30% increase or decrease in total number of entries in a short period of time, and that some repositories have experienced issues, such as temporary inaccessibility. To what extent is the VRP changes caused by these issues acceptable? Everyone, please think about it too. Okay. We concluded that it would be impossible to consistently retrieve perfect ROS from all repositories due to the way RP cache systems. And we thought about how to solve this problem with validator. Many validators currently available have the ability to monitor the ROA acquisition status, but do not have the ability to stop VRP transmission based on the monitoring result. If an incomplete ROS is acquired, it will immediately export an incomplete VRP to the router. Let's go into a bit more detail about how the validator is self-systems. There are two types of validator. One that integrates the acquisition of ROS and the transmission of VRPs using RTRs, and one that is separate. In both cases, the data flow is to acquire ROS and then export them to the router as VRP. But with separate validators, you can extract the VRPs and check their contents before exporting them to the router. To prevent incomplete ROVs, we developed a mechanism that works based on the following requirements and named it VRP breaker. The VRP breaker verifies the ROA acquisition status and VRP. And if no abnormalities are found, it exports the VRP to the router. If an abnormality is found as a result of the verification, it does not export the abnormal VRP to the router and has a mechanism that continues to export the previous generation VRP to the router. We also defined abnormal. We decided to consider an abnormality when the actual measured values deviate by 10% or more from the value predicted using a least square method. This abnormality can be freely set by the organization operating the validator. The figure is an image, so the actual range may be a little wider. I will explain the data flow of a custom validator incorporating VRP breaker. Under usual situation, after retrieving the ROA, verification is performed within the VRP breaker. And if no abnormalities are found, a VRP is sent to the RTR process. The VRP then sent to the router using the RTR, and a normal ROV is performed. In the event of an abnormality, verification is performed within the VRP breaker after retrieving the ROA, just as in the usual case. If an abnormality is confirmed as a result of the verification, the VRP is not sent to the RTR process, and the previous generation VRP continued to be used for a certain period of time, preventing the abnormal VRP from flowing to the router. If the abnormality is resolved, the VRP will be sent to the router again. This is what we can with VRP breaker. you temporarily stop forwarding incomplete VRPs and continue to using complete VRPs, thereby preventing important routes from becoming not found, making the implementation of RPKI more secure. I will also share some of the challenges VRP Breaker currently faces. The first is that it is unclear whether this function can be implemented in all validators. We need to investigate whether a similar implementation is possible in software other than the one used for the validation. The second point concerns the criteria for setting abnormal values. In our VRP breaker, we used the least square method to verify the fluctuations in the total number of ROS per repository. However, it is unclear whether this method is optimal, and we need to consider researching better algorithms and setting criteria for values. We also believe that verification criteria other than the total number of ROS are necessary. I'd like to talk about our future prospects. We implemented the VRP breaker as an external component of RPKI client and are currently testing whether the same can be done with Routinator. Going forward, we will test whether the VRP breaker can be used with other validator software, not just Routinator. We also plan to continue collecting monitoring data on the values used for validation and to continue discussion and testing. Furthermore, since the VRP breaker is a technology that is being considered for commercial adoption by S2518 Biglobe.inc, we will continue to improve it to ensure safer and more efficient operation. This concludes my presentation. Currently, many organization policy is not to reject not found route. So using an incomplete VRP doesn't have a significant impact. However, starts a policy of rejecting not found routes. The problems caused by incomplete VRPs will become very serious. Therefore, we will need to continue to consider more reliable validators. This research has supported by University of Nagasaki Professor Masayuki Okada and Biglobe.inc Katsushi Yamaguchi. Thank you very much.
Thank you, Taiju. If you have any question or comments, we will have one question or comments. Our time is 2 minutes left. No questions or comments? Okay. So thank you, Taiju. And if you have any comments or questions, please come to him. And Hai is here, and he will down to the floor after this. And the Zhu Tao Liu, is there Zhu Tao Liu? No? No, okay. If any comments or question or hard disk for him, please come to him and let's talk each other. Thank you, Taiju.
Thank you.
Okay, thank you for attending until the end. And next time we will have chair and we will have more interaction or interesting presentation. Before the end of this session, please give large applause for staff on the floor. This session was prepared half a year, I think, and they give very nice sessions. Thank you. Okay, the session is closed. Thank you.